Hi, hello students, good evening everyone. I hope all are doing well. Anyway, welcome back all of you to the Infinity Learn JEE YouTube channel. This is me Surya, your chemistry faculty from Infinity Learn. Okay, I believe I am perfectly audible and visible to each and everyone present over here. Okay, we will be moving to the next part of our same chapter, Biomolecules. In the previous class, we have discussed about the classification of carbohydrates. In this particular session, we are going to discuss the structure of glucose along with their open chain as well as the cyclic structure. Okay, fine. I hope you guys have revised to the topics that we have covered in the last class. Now we will be moving to the structure of carbohydrates. Before that, there is a general reminder about the AATS, All India Test Series. You will get a 50% discount of 299 of discount about the by using YouTube 50 off code. So just enroll fast. Okay, let us start with the structure of glucose. As you already know what you mean by glucose, right? These are the dextrose structures. Or we can say that glucose is an aldohexose. Aldohexose means it contains aldehyde group having 6 number of carbon atoms, right? Aldohexose. And it is having the rotation about the dextrorotatory, so this is known as the dextrose. So we can say that glucose is the monomer of always all the larger carbohydrates such as starch, cellulose. We already shown in the previous classes, right? Now let us start with the structure of the glucose. Okay, there are some evidences or the chemical experiments have been done to explain the open chain structure of the glucose. Let us see the experiments one by one. Okay, the first one about the molecular formula, it is found to be C6H12O6, as we already know, right? Glucose is having the molecular formula of about C6H12O6, which means it contains 6 carbon atoms follows hexose molecule, right? Now the second one, what is the arrangement of these 6 carbon atoms, right? Whether it is the branched chain or the straight chain. So that the experiments done that whenever this glucose molecule heated with the HI molecule, on prolonged heating with HI molecule, it forms normal hexane. It forms normal hexane. As you can see over here, this is the experiment or the reaction happening here. This is our glucose molecule. Whenever it is heating with the HI molecule, it will form the normal hexane, right? It will form the normal hexane. Right. So we can have an evidence that all the 6 carbon atoms present in the glucose molecule is in a straight chain carbon, right? All the 6 carbon atoms are linked in a straight chain. That is why normal hexane is formed due to the reaction between HI and the glucose. Clear? Now the second thing we have to be identify that what is the functional group which is present in the glucose molecule. So that we have done an experiment with the hydroxyl amine. Hydroxyl amine is the one of the reagent used here. It shows that glucose reacts with hydroxyl amine to form an oxime. Similarly, whenever it is added with an amount of hydrogen cyanide, that is HCl to form cyanohydrine. So this indicates that the glucose molecule must contain a carbonyl group, C double bond or group in the glucose, right? Let us see the reaction here. Okay, this is our glucose molecule. NH2OH is known as the hydroxyl amine. Whenever these hydroxyl amine react to the glucose molecules to form, this is the molecule having CH double bond NOH is known as the oxy molecule. This will be our glucose molecule. It contains aldehyde group here. CHOH 4 times CH2OH. Right? So, there will be release of H2O molecule, that is water molecule, then it will form the oxygen molecule, right? Oxygen molecule. So this is the actual reaction that is happening in between the reaction of hydroxyl amine and the glucose molecule. It will form oxygen, which indicates the presence of a carbonyl group, C double bond or group present in the glucose. Similarly, the second reaction, that is the reaction with hydrogen cyanide, right? Hydrogen cyanide, it is HCN. HCN, hydrogen cyanide. So whenever we are treating with the glucose molecule, it will form the another compound known as the cyanohydrin. Cyanohydrin. So again we can say that whenever these HCl react with the glucose molecule, indicates that there will be the presence of carbonyl group in the glucose. Clear? Okay, whenever there is a reaction between hydrogen cyanide, right, the glucose react with the hydrogen cyanide to form cyanohydrin, which indicates the presence of carbonyl group in the case of glucose molecules, right? So we confirm that there will be a presence of carbonyl group in the case of glucose molecule. The next thing we have to be noted that whether the carbonyl group contains is aldehyde or ketone, right? There are two types of carbonyl groups, right? Aldehyde or ketone, both have the same carbonyl group here. So we are doing the another experiment here. Glucose gets oxidized to 6-carbon carboxylic acid on reaction with a mild oxidizing agent like bromine water. Whenever we are using any of the oxidizing agent, right? For example, we are using the mild oxidizing agent of bromine water here. The glucose will oxidize to form 6-carbon carboxylic acid known as the gluconic acid. Let us see the example here. Let us see the reaction here. Okay, this is our glucose molecule, right? This will be the carbonyl group. Whenever this is reacting with bromine water, which is the mild oxidizing agent, these carbonyl group get oxidized to form acid group, right? COOH. Okay, this is a 6-carbon containing acid group, so this name is known as gluconic acid. Gluconic acid, right? So we can predict that the carbonyl group that present in the glucose must be an aldehyde group. Clear? So far we discussed about the functional group that present in the glucose molecule, right? As first we saw that there will be a carbonyl group. Now we identify that the carbonyl group that present in the glucose is a aldehyde group. Now the next thing we have to be identified that the carbon atoms that are present in the glucose, right? Carbon atoms that are present in the glucose, that is 6 carbon atoms are present along with some hydroxy groups, right? Along with some hydroxy groups, as we already know, the glucose is a polyhydroxy aldehyde, right? So we have to identify the presence of OH groups, presence of hydroxyl groups here. For that we are doing the acetylation of glucose. Acetylation of glucose, which means that glucose is reacting with the acetic anhydride. Acetic anhydride, it will form glucose pentaacetate. Glucose pentaacetate, which indicates the presence of 5 OH groups in the case of glucose molecule. Let us see the reaction here. Right, the reaction between acetic anhydride, it will form glucose pentaacetate, which indicates that here 4 OH groups present in the glucose will react with acetic anhydride to form pentaacetate, right? So here 4 hydrogen along with this one hydroxyl group, right? Hydroxyl group, total 5 hydroxyl groups are present in the case of glucose. This reaction indicates the presence of 5 OH groups in the case of glucose molecule, right? Clear? The last evidence to find out the structure of glucose is the reaction between strong oxidizing agent. The reaction between strong oxidizing agent like nitric acid, right? Nitric acid. So we are taking here our glucose, right? Here the nitric acid acts as a strong oxidizing agent. So here the primary OH group, right? Primary hydroxyl group will also oxidize to form acid group here. So this compound is known as saccharinic acid. Then as we already know, there is a gluconic acid present, right? Whenever we are using the bromine water oxidation here, it will form gluconic acid, right? This is our gluconic acid, which is produced from the reaction between bromine water and the glucose. This will also react with the nitric acid, the strong oxidizing agent here, to form the same saccharinic acid having 2 carboxylic acid group. Clear? So this reaction indicates the presence of a primary alcoholic group in the glucose. This primary alcoholic group. Clear? Based on these experiments, finally we have discovered about the open chain structure of glucose. As you can see over here, the glucose was given the open chain structure by Bayer. And this is the Fischer projection formula for the glucose here. The first group given is the aldehyde group, right? We already confirmed the presence of aldehyde group during some reactions. Then it contains 1, 2, 3, 4, 5, right? 5 OH groups are present. So this is a polyhydroxy. Aldehyde, right? Polyhydroxy aldehyde. So this is our D-glucose because it has a similar configuration or the structure about the D-glyceraldehyde. So we can call it as a D-glucose molecule. Then this will be the Fischer projection formula for the glucose molecule. We have already given about the open chain structure of glucose, right? Open chain structure of glucose. We already shown that in the case of an glucose molecule, there will be aldehyde group. So it should give all the positive tests with the reagents, right? For example, if you are taking Schiff's reagent or sodium bisulfate reagent, it should give the positive result, right? Because they contain aldehyde group. But the thing is that whenever the glucose is reacting with the Schiff's reagent or the sodium bisulfate, it does not give any positive result, which means that it indicates the absence of aldehyde group here. Even though it is having aldehyde group also, it does not give positive test with the Schiff's reagent and the sodium bisulfite. This is one of the drawback or the limitation of the open chain structure. Then the second thing is that glucose pentaacetate, that is the product which is formed by the reaction between acetylation of glucose, right? So the glucose pentaacetate does not react with hydroxyl amine, NH2OH, right? Hydroxyl amine, which indicates that there will be the absence of free CH group. As we already seen that in the case of structure, right? This is the aldehyde group present over here in the case of glucose molecule. This is the free aldehyde group, right? Free aldehyde group. Whenever any free aldehyde group is present in any of the compound, it should react with the hydroxyl amine. It should react with the hydroxyl amine to form the oxime reagent, right? Oxime product. So whenever we are treating the glucose pentaacetate with the hydroxyl amine, it indicates that the absence of aldehyde group. This is the another limitation of the open chain structure of glucose. The last one it is that glucose is found to exist in two different crystalline forms. These are alpha and beta forms. There are two types of isomers. We can call it as isomers having the similar chemical formula having different configuration, right? So we can call it as isomers. Otherwise, this name is known as anomers. This is another type of isomers in the case of glucose. There will be alpha and beta. The only difference is that it has the configuration different in the case of first carbon atom. Let us see in detail. Clear? So in order to overcome the limitations which came by the open chain structure of glucose, another structure was proposed based on the cyclic structure, that is known as the cyclic structure of glucose here. As you can see here, this is a structure of glucose, right? This is our Fischer projection formula of the glucose. And the thing is that, right, this is our aldehyde group is present here. Okay, this is our aldehyde group present here. So in the case of, this is first, second, third, fourth, fifth, right? OH, oxygen is having the more electronegativity, so it will be minus, it will be plus. Then here is also, it will be minus, the carbon is having plus charge, right? Carbon is having plus charge. Then what will happen here, right? These oxygen, right? These oxygen having negative charge will go to the positive carbon here in the first carbon. Are you getting my point? Here the negative oxygen will go to the first carbon atom having the positive charge, right? Now what else? Here the oxygen is having negative charge, right? So this hydrogen will go to this oxygen to form this structure here, right? See, OH is here, right? The oxygen with hydrogen, OH is here, one hydrogen is here. Then this similar properties, HOH, OHH, fourth carbon is HOH, fifth carbon, here is a bond, right? This bond is moving from here. See, having the bond in between, there is an oxygen is present. Clear? An oxygen is present in between first carbon atom and the fifth carbon atom. This structure is known as a hemiacetal structure. Hemiacetal structure. So it was proposed that one of the OH groups may add to the CHO group and form a cyclic hemiacetal structure. Cyclic hemiacetal structure. Then it was found that glucose forms 6-membered ring in which OH at C5, fifth position, carbon at the fifth position, OH in the fifth position carbon, involved in the ring formation, right? Involved in the ring formation. So it indicates the absence of free aldehyde group present over in the case of glucose molecule. Clear? Okay, I am repeating once again. This is the fifth carbon atom, right? This is the fifth carbon atom. The oxygen present in the fifth carbon atom, OH group present in the fifth carbon atom react with the first carbon atom to form a hemiacetal structure over here. So this will be the hemiacetal structure for the, this is beta D glucose, this is the alpha D glucose. So this is the hemiacetal structure. So we can say that if you are focusing on the first carbon atom only, you can say that OH group is on the right side, right? OH group is on the right side. OH group is on the right side. So here OH group is on the left side, right? OH group is on the left side. So the isomers having the configuration different at the first carbon atom, that is known as the anomers. Here it is the alpha D plus glucose and here it is the beta D plus glucose. Clear? From this we are introducing the cyclic structure of glucose. Here alpha and beta stands for the anomers, D stands for the similarity with the D-glyceraldehyde, right? Then plus stands for the dextrorotatory, which has the ability to rotate the plane polarized light to right side, right? Plus or clockwise or dextrorotatory. Clear? So finally we are introducing the cyclic structure of glucose. Then whenever we are discussing about a cyclic structure of glucose has a similarity with the pyrene, right? This is our pyrene, this is the cyclic compound having the oxygen atom present here, right? This is the pyrene structure. So we can compare the structure of cyclic structure of glucose along with the pyrene group. So this will be the cyclic structure having 6-membered ring pyranose containing 5 carbon atoms and 1 oxygen atom like pyrene. As you can see over here, this is a 6-membered ring here having 1 oxygen atom and having 5-membered ring, right? 1 oxygen atom formed like, okay, not 5-membered, this is 6-membered, right? 1 oxygen atom and 5 carbon atoms here, right? This is the pyranose structure. Right? So there is a simple trick to write the cyclic structure of glucose molecule or any other molecule. This cyclic structure is known as the Haworth projection formula. Haworth projection formula. Haworth projection formula. The main thing is that whenever any of the group which is present on the right side, right, present on the right side, you should be written in the bottom of the plane, right, bottom. For example, if I am taking this molecule, right, alpha form of the glucose, here the OH is on the right side, so I am taking in the below of the plane here or bottom here. Then here it is again OH, right, bottom, H bottom, OH bottom. The last one CH2OH, right? Are you getting my point? How to draw the Haworth projection formula from the Fisher projection formula. Okay, similarly, you can draw the beta D glucose also here. This is the beta form of glucose. The only difference is that first carbon atom having the different configuration of OH, right? Here the OH will be in the right side. In the case of beta form, OH will be in the left side. So, whenever you are having any of the groups in the right side of the Fisher projection, it should be in the downside of the Haworth projection formula, right? So, here it is hydrogen, downside. Here it is hydroxyl, OH group, right? Again downside, hydrogen, OH, then finally CH2OH, right? This will be the Haworth projection formula for the beta D plus glucose. Clear? Similarly, you can draw the Haworth projection formula for fructose also. The only difference is that the fructose is having the ketone group, right? So, it is called the polyhydroxy ketose group, and it has a similar structure to that of the furan. So, it is called polyhydroxy furanose. Clear? Okay, that's all about the structure about the glucose. We have studied about the open chain structure of the glucose, right? We are starting from some of the reactions here. Okay, right. The first one, it found to be the molecular formula around 6,6H12O6. Then, whenever it is heating along with the prolonged heating with the HI molecules, it will form the normal hexane, right? So, it indicates that the 6 carbon atoms which is present in the glucose molecule is in the straight chain structure, right? So, it will form N-hexane. The next reaction it is that it will react with the hydroxyl amine or the cyanohydrin, right? Whenever it is reacting with the hydroxyl amine, it will form the oxime. Similarly, when it is reacting with the hydrogen cyanide, it will form the cyanohydrin, which indicates that the glucose molecule must contain a carbonyl group in that. Clear? Then we have to identify which is the carbonyl group present in the glucose molecule. That should be aldehyde group. We are taking the reaction here. Whenever we are doing the oxidation, right, while using the mild oxidizing agent of bromine water, it will form a 6-carbon carboxylic acid known as the gluconic acid, which indicates that the carbonyl group that present in the glucose is a aldehyde group, right? Now we have to indicate that we have to identify the presence of OH groups there. So we are doing the acetylation of glucose with the acetic anhydride. So it will form glucose pentaacetate, which indicates that the compound must contain 5 different OH groups, right? 5 different OH groups. Then we already know there are polyhydroxy groups, right? 5 hydroxy groups are present. We have to identify whether there is any presence of primary alcoholic group in the case of glucose. So we are doing the oxidation with the nitric acid, which is act as a strong oxidizing agent here. So here the glucose whenever react with strong oxidizing agent like nitric acid, it will form a dicarboxylic acid, right? Dicarboxylic acid to form a saccharic acid, which indicates that there is a presence of primary alcoholic group in the case of glucose, right? This will be the evidence for the structure of open chain structure of the glucose. Okay, this will be the Fischer projection formula for the glucose. In order to predict the structure completely, it fails to follow in these things, right? Whenever they are containing free aldehyde group also, it fails to have the positive test with the Schiff's reagent and NaCO3. So we have to identify whether there is a free aldehyde group present in glucose or not. So we are doing the cycling structure here. So we can say that the fifth carbon atom, the OH group present in the fifth carbon atom in the glucose will react with the first carbon atom in the glucose to form a hemi-acetal structure. This will indicate that there is no any free aldehyde group in the case of glucose molecule, right? So we can draw the structure in form of a Haworth projection, that is a cyclic structure of the glucose molecule, that is known as the Haworth projection formula. The simple thing you have to be noted that whenever you are giving the Fischer projection formula, right? Fischer projection formula, you can easily able to write the Haworth projection formula by using the trick that whenever any group which is present in the case of right side of the Fischer projection formula, it should be in the bottom side of the Haworth projection and vice versa. Clear? Then one more thing you have to be noted that about the anomers, right? Anomers is the type of isomers which is present in the case of glucose, which has the different configuration at the first carbon atom, that is alpha and beta glucose. Now let us practice some questions. Here is the first question for you. We have already discussed about the different types of saccharides, carbohydrates, right? We have seen about the monosaccharides, disaccharides, oligosaccharides and polysaccharides. Here the question is based on the monosaccharides of maltose. What are the monosaccharides which is used in the case of maltose? The options are given here: alpha D glucose and alpha D glucose, beta D glucose and alpha D glucose, and option 3 alpha D glucose and alpha D fructose, and last one alpha D glucose and beta D fructose. You must have an idea about the monosaccharides in the case of all the disaccharides which is we already studied, sucrose, maltose and lactose. Here the option 1 will be the correct answer, that is alpha D glucose, right? Whenever two alpha D glucose molecules are combined together, as you can see over here, right? Combined together, we can say that there will be the glycosidic linkage between here, right? There will be the 1,4 glycosidic linkage between 2 alpha D glucose in the case of maltose molecule, right? Here is the next question. The glycosidic linkage between C1 of alpha glucose and C2 of beta fructose. C1 of alpha glucose and C2 of beta fructose. Identify the disaccharide. You must have an idea about the disaccharide which is formed between the alpha glucose and beta fructose, right? That will be the sucrose. Option 2 will be the correct answer. Okay, this will be the structure of sucrose molecules. Whenever alpha glucose, right? Alpha glucose then beta fructose, right? Beta fructose combined together, it will form again 1,4 glycosidic linkage, right? 1,4 glycosidic linkage. So C1, here the numbering should be start from here only for the fructose molecule. Right, so this will be the 1,2 glycosidic linkage. 1,2 glycosidic linkage. Clear? Option B, sucrose will be the correct answer. Okay, here is the next question. The acetylation of glucose with acetic anhydride gives a product X. The number of sp2 hybridized carbon atoms present in one molecule of a compound X is. First you have to identify about the acetylation of glucose. What will be the product? Then identify the number of sp2 hybridized carbon atoms in it. This question is based on the evidence of open chain structure of glucose, right? Right, sp2 hybridized carbon atoms here. This is one of the carbonyl group having the sp2 hybridization. This is the first one. Then what about here in the case of acetic anhydride? CO group is present here, right? Total 4 CO groups are present here, which means that 4 sp2 hybridized carbon atoms are present in this particular section, right? 4 sp2 hybridized carbon atom. Then last one, it is again one CO group, right? Having one sp2 hybridized carbon atom. So in total 4 plus 2, 6 sp2 hybridized carbon atoms are present in the product of acetylation of glucose. This product is known as glucose pentaacetate. Glucose pentaacetate. Option B, option 2 will be the correct answer, 6. Okay, here is the next question. Which one of the following compounds contains beta C1C4 glycosidic linkage? Beta C1C4 glycosidic linkage. Here the monosaccharides are not given, so you have to identify which one may be the disaccharide formed by the glycosidic linkage. Beta C1C4 linkage, which means that 2 monosaccharides present in the case of these disaccharides should be beta form, right? Beta form. Lactose will be the correct answer. As you can see over here, this is the structure of lactose, right? Structure of lactose. Lactose is formed by the combination of beta galactose, right? This is the beta galactose. This is our beta glucose, right? Beta galactose and beta glucose. As we already know, glucose and galactose are the C4 epimers, right? These are the C4 epimers. So here you can see that the first carbon of the galactose will combine with the fourth carbon, right? Fourth carbon of the beta glucose to form 1,4-glycosidic linkage. 1,4-glycosidic linkage in the case of lactose molecule. Clear? Okay, here is the next question, again based on the evidences for the open chain structure of the glucose. The presence of primary alcoholic group in glucose can be explained by. Different reactions are given here. You have to identify how we can predict the presence of primary alcoholic group in the case of glucose molecule. Option 4, right? Oxidation of the glucose and gluconic acid with the concentrated nitric acid, which is a strong oxidation here, strong oxidizing agent here. Whenever glucose or the gluconic acid react with the concentrated HNO3 or concentrated nitric acid, it will form the dicarboxylic acid known as a saccharic acid, which means that the OH group which is present in the glucose molecule is the primary alcoholic group. It is also going oxidation to form the carboxylic acid group, right? Carboxylic acid group. This will be our primary alcoholic group here. Clear? Now here is the next question. Regarding cellulose, correct statements are, we have already seen about the cellulose, right? Cellulose is a polysaccharide. Cellulose, you have to identify which are the correct statements here. The statements given as it is a linear polysaccharide. It is most abundant organic compound in plant kingdom. It is rigid. It is a predominant constituent of cell wall of plant, and it involves C1 C4 glycosidyl linkage between alpha glucose units. All the statements like A, B, C, D are the correct statements here, right? A, B, C, D are the correct statements here. Only the wrong statement is that there will be the C1, C4 glycosidyl linkage between alpha glucose units, right? It will be the wrong one. Just check what will be the glycosidyl linkage. This will be the homework for you. What is the glycosidyl linkage present in cellulose molecule? Okay, here is the next question. Lactose involves a glycosidyl linkage between. The simple question is that what is the monosaccharide which is present in the lactose molecule? Option 4, right? C1 of beta D galactopyranose, which means this is simply our galactose molecule. It is have a similar structure that of the pyran group, so it is known as galactopyranose. So galactose, that is beta D galactose, beta D galactose. Then beta D glucopyranose, again pyran group has a similarity with the structure, right? So this is known as the beta D glucose. Beta D glucose. Whenever these glucose and galactose, beta D glucose and beta D galactose combine together, there will be the 1,4 glycosidyl linkage between these molecules, right? So this will be the 1,4 glycosidyl linkage present in the case of lactose is in between C1 of beta D galactopyranose and the C4 of beta D glucopyranose. Option 4 will be the correct answer. Okay, here is the next question. A disaccharide X cannot be oxidized by bromine water. It cannot be oxidized by bromine water. The acid hydrolysis of X leads to a levorotatory solution. A levorotatory solution. The disaccharide X is. Read the question carefully. The question is given that a disaccharide cannot be oxidized by bromine water, right? Cannot be oxidized by bromine water. So, the acid hydrolysis of the same disaccharide leads to a levorotatory solution. The disaccharide X is. Okay, we already know that levorotatory solution. It may be fructose molecule, right? It may be the fructose molecule. So, we must have an idea about the hydrolysis of disaccharides forming the different monosaccharides. As we already know, sucrose will undergo hydrolysis to form glucose and fructose, right? Glucose and fructose. So, one of the product will be fructose here. One of the product will be fructose here having the levorotatory solution. Then we already know sucrose, right? Sucrose is a disaccharide. It cannot be oxidized by the bromine water. It will not form any product with the bromine water. So we can say that the answer will be sucrose. Now we have to identify which is the structure of the sucrose along these four options. Which is the structure of sucrose molecules along these four options. Option 1, right? Okay. This is our glucose molecule. This is our fructose molecule. Both are alpha glucose and alpha fructose. This is the structure of furan group. So it is known as the fructofuranos also. So we can saw over here, this is the first carbon, second, third, fourth, right? Again, first, second, third, fourth, fifth and sixth, which means that there is the 1,4 glycosidic linkage between alpha glucose and alpha fructose in the case of sucrose molecule. So this will be the structure of sucrose molecule. So the correct answer here is the sucrose having the structure of first option. Clear? Okay, this is all from my side for today. So far we have discussed about the structure of carbohydrates, right? We have started our biomolecules chapter from the structure of carbohydrates, classification of carbohydrates from monosaccharides, disaccharides, polysaccharides and oligosaccharides. Now in this particular session we have discussed about the structure of carbohydrates including the structure of glucose as well as open chain structure and the cyclic structure. In this particular session we have discussed about the structure. This is very important about your JEE Main examination point of view. So that's all from my side for today. Thank you all of you. And I will be coming back with the next session with the proteins and amino acid structure. So don't forget to like the session and share the session also. Subscribe our YouTube channel also. Till then, bye bye all of you. Thank you so much.